So they've given us this question. They want the reciprocal function. They've given it to like this. They want us to recognize that we're working with a linear function to start with, right? So in order to find any vertical asymptotes, essentially we need to find our x-intercept of our linear, okay? So in order to do that, we take the bottom of the reciprocal function, we set it equal to 0, right? Which is pretty straightforward. X minus 3 equals 0. X cannot equal 3. In other words, we have a vertical asymptote there, okay? How about horizontal asymptote? Do you remember doing that stuff with your limits? Me and you covered it, didn't we? Yeah. Okay, let's talk about it. When we're looking at this, our highest variable is x to the power of 1. So I'm going to divide every term in this by x to the power of 1. So we're finding the limit. So f at x as the limit as x approaches infinity. We're going to get 1 divided by x over x minus 3. Is this ringing a bell at all? Yeah. Divided by x divided by x. Okay? Okay. Now, essentially, let's plug in x is approaching infinity. So let's plug in infinity for x. So this will be an infinitely small number. 1 divided by infinity, essentially a 0. Okay? Infinity divided by infinity is going to be 1. Does that make sense to you?
Yeah.
And again, 3 divided by infinity is essentially a 0. So we're going to end up with 0 over 1 minus 0, which gives us 0 over 1, which is 0. So what is our horizontal asymptote? 0. So in that case, y cannot equal the number 0. So when we go to graph this, we'll quickly put this on a graph. Okay, we have a. Oh, we must have got a graph of numbers. Let's go with a little better. There we go. We had a vertical asymptote, we said, at positive 3. So a vertical asymptote right here. And we had a horizontal asymptote at 0. Okay? So we know those are vertical and horizontal asymptotes. What we can try to find now is we can try to find, we know there are no x-intercepts, right? Because there's a horizontal asymptote here. And we can try to find a y-intercept. So we're going to find our y-intercept. So we're going to take the original reciprocal function, which was our f at x is equal to 1 over x minus 3. And when we're finding a y-intercept, we're looking at when x is what value? 0. So we're going to plug it in. It's pretty simple. We're going to end up with f at x is equal to 1 over 0 minus 3. Where's our y-intercept? 1 over negative 3. Important. Okay. So our y-intercept is x is 0, y is negative 1 over 3. Okay. That negative is very important here, because essentially what that's telling us is this line is crossing the y-intercept at negative 1 over 3, which is down here. Had it been positive 1 over 3, and remember we have a horizontal asymptote, I would have been drawing a graph that looked like this. But because it's below, we definitely know it's going to be heading downwards, right? Which then means we go like this. Okay. Another way we can tell that it's from quadrant 3 to quadrant 1 is because we had a positive reciprocal function. This was technically positive, right? Our number. Now, when we get into quotient functions, where this is just a quick side, we have a variable on top and variables on bottom, then it's not so simple with this being positive or negative. Okay, that's when the y and x-intercepts become very important. They help us plot those functions. Okay, let's view all of this. Okay, So domain and range of these functions, right? Our domain is, we know that x is the set of all real numbers. X is every real number. Except that, what can x equal? Was our vertical asymptote. We solved it way up here. Cannot equal 3. X cannot equal 3. Our range. Y is the set of all real numbers, except that y cannot equal what number?
0.
0. We had a horizontal asymptote there. So we have our domain and range. Positive and negative intervals.
What do you mean by that?
Okay. That's when x is positive and y is positive. What do the others go? So one way they rate this in calculus is they go as x is approaching our vertical asymptote. That's what's important. So when x is approaching the vertical asymptote, which is 3, so as x approaches 3, and we would use a positive sign saying, that means from the right, because positive's to the right. That means y will be approaching, so I'm going to show it to you on a graph. So as x is approaching 3 from the right, see how I'm coming from the right side?
Yeah.
What's y approaching? It's going up to infinity.
Oh, I didn't learn this.
You've learned this?
Yeah.
Oh, okay, good. Y is approaching positive infinity. Okay? So that's one of our sets. Our second set, as x is approaching 3 from the left, okay, I put a negative sign, that means it's from the left. Y is approaching what? Negative infinity. We'll just take a quick look at it. As x is approaching 3 from the left, y is approaching negative infinity. Does that make sense?
Yep.
Okay, those are positive and negative intervals. Oh, sorry, those are intervals increase and decrease. And if we want to talk about positive and negative, technically, when x is greater than 3, so when x is greater than 3, y is what? Yeah, well, it's positive. Okay, that would be our positive and negative intervals. Anything to the right or greater than positive 3 on the x, y is positive. And anything less than positive 3, y is negative. So kind of write that down. I can't quite remember I don't know if you have a set notation for that, but when x is greater than 3, y is positive. Or it could be like y positive. I'm not sure what notation they want. Okay. And when x is less than 3, y is negative. Let's take a look. F of x is positive when x is or negative infinity. And negative, let me just make sense of that so I know how to write properly. Okay, so they may want us to write it like this. These were increasing, so I wrote it this way for increasing, but it looks in your book, they want it a little different. There we go, so move those down. So essentially, we were saying, when we look at this, okay, when we're going left and right, we're decreasing to the left when we're negative infinity to 2, from negative infinity to 2 on the x. So what they say is, specific wording, do they say f of x? No. It is increase. So in this case, we are decreasing. So decreasing from xer. So when we're moving along x, the x-axis, we're decreasing from negative infinity to 2. Okay, so in other words, as soon as we start it, we're at negative infinity, we instantly started coming down, 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 and then all the way to 2. Then eventually at 2 it stops, right? Yeah. So that's why we have to split this. But we start up again after 2, and we're still continuously decreasing. Have you noticed that? Yeah. We're going from left to right, we're still coming down. So we are decreasing when xer from negative infinity to 2, and from 2 to infinity. We're decreasing at both those points. Does that make sense to you?
Yep.
Okay. So this is a calculus way to write it. And up here, limit, and here's your decreasing. Okay. And then positive and negative. This function is positive, so they would write it like this: f at x, in other words, our y, f at x is positive in this interval. It's positive when not r. We're replacing not set of all real numbers. We're replacing it with our two intervals on our x. So f at x is positive. In other words, y is positive when we're going from 2, that's this point here, all the way to positive infinity. That's when y is positive, or f at x is positive. Does that make sense?
Yep.
Okay. So it's positive from 2 to infinity, and f at x is negative when xer is negative infinity to 2. So in other words, when we're going along here, from negative infinity all the way to 2, f at x, or y, is a negative number. Does that make sense?
Yep.
Okay, so let's check out that calculator. Ooh, it's a bit small. Let's zoom in a little. So this is everything we did. We found the reciprocal, found the vertical and horizontal asymptotes, found the Y-intercept, so we kind of knew how to graph it. We stated the range and domain, then we put the intervals of increasing and decreasing, and we put when the function was positive and negative. So we had our quadratic function. We put it into reciprocal form, and we knew that once we factored it, we did that in red on the side here, 2d minus 3, 3d minus 1, and we found that our X intercepts, and because I'm calling them X intercepts, we stipulated at the top that d equals x, so we're going to work in x from now on. X cannot equal negative 3 over 2, and x cannot equal 1 over 3, right?
Yeah.
Let's also try to find our horizontal asymptote. Okay, so we found our vertical asymptotes. Horizontal asymptote. F at, I'm going to change it to x now, and the limit of x approaching infinity. So we're changing all the d's to x's. Okay? We're going to divide every term we know by our highest variable, and that would be in our other one. We're going to go back to the standard form of the equation, okay? So that's going to be x squared. So we have 6x squared plus 7x minus 3. And we're going to divide everything by x squared. That's our highest degree of a variable, okay? X squared, x squared, x squared. Well, as x approaches infinity, we take a look at this. We get 1 divided by infinity divided by 6 times infinity squared, okay? Plus, squared, 7 times infinity squared. What is this? Infinity squared. Minus 3 by infinity squared. Alright, we know that infinity squared is just infinity, okay? So we get these. You can't really go any higher than this. So we get our infinite numbers, okay? We replace them with. What is 1 divided by infinity going to be? Infinitely small. So we know it's going to be 0. These infinities will cancel each other out. Right? So we're going to have 6 plus 7. That's going to be 0 minus 0. But what is our answer going to be in the end? 0. So what's our horizontal asymptote?
0.
Yeah, so y cannot equal 0. So let's go and quickly plot what we got. So we had vertical asymptotes. What were our two vertical asymptotes? 1 over 3, so a third. So that's probably about here. And what's the other one? -3 over 2. So that's -1/2, right?
Yeah.
So we have our 2 here. And we also had a horizontal asymptote, we knew, at 0. So we know we have no X-intercept. Okay? Our Y-intercept is going to be in between. So we can solve for our Y-intercept. And we'll do that quickly. Our original equation is f at x. And when we're solving for a Y-intercept, it's actually f at 0, because that's when x is 0, is equal to 1 over 6 times 0 squared plus 7 times 0. What was our last number? -3. So what do we end up getting? 1 over 0 plus 0 minus 3. 1 over -3. So our y-intercept is 0 and -3, or -1/3, which again is down here, right? Do it in red. So we're down here. So we have our y-intercepts. We know we don't have any x-intercepts. Now, if we're getting in trouble in drawing the graph, remember, you know that we can technically set numbers equal to other numbers. We can try to solve for when y is here, or when y is -1, right? And we're going to get several answers there, 2 answers. But we know because this is quadratic, and this is below our horizontal asymptote, we know we're going to have some quadratic function down like this, correct?
Yep.
Which means the rest of this is going to look like this. Does this make sense?
So how do you know that the middle is going downwards?
We know it's downwards because our y-intercept, which fell in between, was below the horizontal asymptote. So in other words, we couldn't have a quadratic coming up through here because we know we can't cross the x-axis. So we knew it had to be facing downwards. So because it had to be facing downwards, these two have to be up here. That makes sense? All right, let's talk about intervals of increase and decrease and all of that amazing fun stuff. Okay. Do you want to do positive and negative or increasing, decreasing first?
Positive, negative.
Okay. So f at x, which is essentially y. So think of it as y is positive when, and now we are only talking about x because we've stated we're talking about, we're going to tell you when y is positive or f at x. Now we're only talking about x. So when x is xe, and then we put our bracket. So when is it positive? When is f at x positive? Well, this is one of our cutoffs, which is what number? Negative
3/2.
Yeah. So from this number, from -infinity to -3/2, is y positive?
Yeah.
Yeah, y is positive. So that's going to be one of ours. From -infinity to -3/2, and let's make a little bit of room here. Okay. And it's positive when xer is going from where? Or not xer, but x. I'm going to write down there. We won't have room. When we go from what number? What's our other f at x as well? 1/3 all the way to what number?
It goes to infinity.
Positive infinity. So and when x is from 1/3 to positive infinity. So what we've done is we've stated when y is positive when we're going from -infinity. So anything between -infinity and -3/2. So that's from all the way there to here. And then from here on, it's positive.
Okay.
Now we also have to denote f at x is negative. Okay. When, what are the two things we're between for x?
It's on -1/3 is going to
-3/2 to 1/3. Because these are the 2 points we're between. We're between here and here.
Oh, okay.
So that's the only time this is negative.
Okay.
Is between those two asymptotes. So we're always going to be referring to any vertical asymptotes we have, we're setting these up.
Oh, we're okay.
Okay?
You have to remember that. That's why I got confused.
Okay, does that make sense?
Yeah.
This word is a little harder now. Okay. We would say it's increasing. So, let me say as f of x is increasing here, I guess so. Okay, now, increasing, decreasing intervals. F at x is, I'm just going to use this, increasing, okay? That means increasing. Are you okay with that?
Yeah.
Is increasing when, and here's where we talk about it again. When x is going from where? We're increasing from negative infinity all the way to what? Negative 3 over 2. We're increasing. Okay? When a negative infinity to negative 3 over 2. Okay? Now this is the hard part. Always think we're going from left to right when we read, right? That's how we read. So we go from left to right. Negative infinity to negative 3 over 2. Then we're down here. Am I increasing when I go this direction? Or sorry, when I'm going this direction, is this increasing for a bit? It increases to a point, and then what does it start to do?
Decreases.
Okay. I gotta find that in between. Do you know how to do that? What's going to be the vertex of that little parabola we've drawn? Think of it with our vertical asymptotes. It's going to be the number that is by 2. Yes, so we're going to add it together and divide by 2 to find exactly where that point is. Okay. So think of it like negative 3 over 2 plus 1/3 divided by 2. Okay, that's going to tell us our vertex, or our axis of symmetry, you could say. Okay, so that's going to be negative 9 over 6 plus 2 over 3, no, 2 over 6 divided by 2, which is going to give us, I'm going to move this all down. Okay, these are our side calculations, just to figure out what it's increasing to. Okay, so that's going to give us negative 7 over 6 divided by 2. Does that make sense to you?
Yeah.
Okay. Which is then going to be
Multiplied by half.
yeah, negative 7 over 6. Negative 7 over 12. Which is as a decimal, just so this we can make sense of this. 7 divided 12, 5.83 repeated. So a really small number. We're going to keep it as a fraction.
Yeah.
So f of x is increasing when x is going from negative infinity to negative 3 over 2, and it's increasing when x is going from negative 3 over 2 to our vertex, negative 7 over 12. Does that make sense?
Yeah.
Okay. And then, I'm just going to move our side calculation down a little more, because we've got to do f of x is decreasing too. Okay. F of x is decreasing when x is, and we've got to figure out what it's decreasing. We know it's from the vertex on, right? We're decreasing. So we know when we're going from negative 7 over 12. So at this point, we're starting to decrease again, right? To what's our asymptote? A third?
Yeah.
Right? So we know from those 2 points, from the vertex to a third, we're decreasing. And one last thing. Once I start up here, going left to right, am I increasing or decreasing?
You are decreasing.
Yeah. So from a third to
Infinity.
yeah. From third to
Okay, that makes sense now.
Is that making more sense?
Yeah.
That's a lot of stuff, right? Okay. So we quickly found our x-intercept. We set the bottom equal to 0. X can equal 1. We set the limits for y. Found our horizontal asymptote at a third. That fit? Yes, it will. Great. So, x can't be 1. Got a vertical asymptote there. Horizontal asymptote was a third, so it was like way close, but not quite. Okay, so those are our two asymptotes. Now we can find x-intercepts and y-intercepts. Okay, because our asymptotes don't quite hit them.
Would you presume that is going upwards because it's positive?
Let's double check now because we're working with quotient functions.
Yeah.
It can be a little different. So let's find our x and y-intercepts. So first of all, for to find an x-intercept, that's when y equals 0, right?
Yeah.
So we're looking for the x value. That's when y equals 0. So our function is y being 0 is equal to x minus 1 over, what is it, x?
3x minus 3.
3x minus 3, okay.
And just isolate for x, right?
Well, actually, because we're looking for when y equals 0, I just had to isolate for when the top is 0. Because whenever that equals 0, whatever I divide by is going to be 0. As long as it's not the same number. Did we find one that's the same number? We did. That's what we've done. So, what we discovered is that when x is equal to 1, it's actually a hole in the function here. X equals 1 is, that's going to cause us to have 0 divided by 0. We're going to plug it in. So we're going to actually have a hole in the function when x is at 1.
I thought they have to be the same on the top and bottom.
Yeah, so let's plug that in. So let's see what we can do. So what's happened here is we have y equals 0 minus 1 over, sorry, when x is 1 minus 1, and 3 times 1 minus 3. What do we end up getting? 0 divided by 0. Okay, so we have that